So, hello everyone. Today we discuss about the pH scale. There is nothing but the concept of pH. So, what is the need to introduce a such type of concept is if you take an acid, highly concentrated acid, by the addition of acid, what happens? Its acidic strength decreases. Its acidic strength decreases even by the addition of some more amount, excess amount of the water. Just its concentration become dilute and very dilute, but it never becomes a neutral solution. When an addition of an addition of water to acid, there is no change in the behavior of acid. Maybe its strength decreases, but it never turn into neutral solution. It comes to near to neutral solution. In the same way for base also, if you take the base concentrated base on dilution and infinity dilution also, it becomes near to neutral, but it does not lose its basic character. Okay, means on dilution there is no change in the nature of the acids and bases. But what is the change? There is a change in the strength. For acids, there is a change in the H plus ion concentration. For bases, there is a change in the OH minus ion concentration. There is a change in the H plus ion concentration means even in acids, H plus changes means automatically OH minus also changes. In bases, OH minus concentration changes means H plus also changes. Means to compare the acidic strength, okay, to compare their concentration, a new concept is introduced by Sorensen, that is called the concept of pH scale. So actually at first it was proposed by Sorensen. So it was proposed by Sorensen. Okay, so what is pH scale? So the first we write the formula. Based on formula we write the definition. So pH is equal to minus log H plus, or we can write we know the logarithm formula. That is if you take general logarithm, so it becomes 1 by H plus. So these both formulas are useful to know the pH of a solution. So this is applicable for acids and also for all solution it is applicable. The H plus is there, it is not like that it is only applicable to acids. ఇప్పుడు మనకి డెఫినేషన్లో డెరివేషన్లో హెచ్ ప్లస్ ఉంది, ఫార్ములాలో హెచ్ ప్లస్ ఉంది కాబట్టి సో యాసిడ్స్కి అప్లై అవుతుంది, బేసిస్కి అప్లై కాదు. ఇట్ ఈస్ నాట్ లైక్ దట్. pH scale is applicable for all type of solutions. Okay, acids, bases, for neutral solution, for all solution it is applicable. So but it is totally given in terms of a H plus concentration. So here pH is equal to negative logarithm of H plus. Here the H plus taken in square brackets. We know that square brackets indicate the concentration. Actually the original definition it is given the activeness, the activity of H plus, the activity of proton is called H plus concentration here, which is H plus activity means nothing but equal to H plus molarity. That's why simply we are taking as the H plus concentration. But in original definition it was given that the negative logarithm of H plus proton activity. This for simplicity we make it as a H plus concentration. Okay, means here we can write the definition. So the negative logarithm of activity of H plus. It was the original definition, but now we changed it as the negative logarithm of activity of H plus or concentration of H plus of a solution is called its pH. Okay, it's called P power H or pH. So it can be written in two terms. So now we do this. We apply this pH formula for acids, bases, and neutral solution. So we know that for pure water, so we know that for pure water, okay, at 25 degrees Celsius, what is the H plus concentration? What is the OH minus concentration? It is equal to 1 into, just we are leaving that 1, 10 to the power of minus 7 moles per liter. We are writing it as a molarity. So the Kw value, we know that H plus into H plus concentration into product concentration. The product of H plus and OH minus concentration equal 10 to the power minus 14 mole square per liter square. So we know that at 25 degrees Celsius in pure water, so H plus equal OH minus equal 10 to the power of minus 7 m. So for any temperature, pure water, we can take H plus equal OH minus, but we don't know the concentration value. That's why we are taking at 25 degrees Celsius, H plus concentration is equal to OH minus concentration is equal to 10 to the power minus 7 m. And we know that if H plus is greater than 10 to the power of minus 7, it indicates about acids. Okay, so we are writing the first case. If H plus concentration is greater than 10 to the power minus 7, we say it is an acid. Now we apply this for pH in pH scale. Okay, so 10 to the power, greater than 10 to the power minus 7 means what are the possibilities? So here we can say the H plus equal to greater than 10 to the power minus 7 means 10 power minus 6, even 10 to the power of minus 6.99 also. Just we are taking general for simple calculation కోసం integers తీసుకున్నాం. We are not taking the fractions. 7 exactly 10 power minus 7 ఉంటేనే that is the neutral, we know that is for pure water. అయితే 10 power minus 7 కంటే if is highest, that will be treated as acidic. 10 power minus 7 కంటే highest అంటే 10 power minus 6.9 also is greater than the 10 power minus 7. Okay, so but for simple calculation we are taking as 10 power 6, 10 power 5, minus 5, minus 4, minus 3, minus 2, minus 1. So all these are possible values for H plus is greater than 10 power minus 7. So these are for acids. Okay, these are all treated as acids. Now apply the pH formula. What is the pH formula? pH equal to minus log H plus. So if you take so we are doing general calculations, minus, if you take H plus equal to 10 power minus 6, so the power comes to the starting and the pH equal becomes minus 6 minus becomes plus 6 log 10. We know that log 10 value 1, so the pH is equal 6 into 1 means 6. Means if you take the concentration of H plus 10 power minus 6, we got pH equal say 6. So similarly we can write if you take the 10 power minus 5, we will get pH equal to we got the 6, 5. If you take minus 4, we will get 4. If you get minus 3, we will get 3, 2, 1. Even if you take some more, that will get 0. Means all these pH values indicates about acids. So all మనకి H plus concentration for acids తెలుసు. H plus concentration for acids ఏంటిది? Greater than 10 power minus 7. Greater than minus 7 అంటే what are the possibilities? Minus 6, minus 5, minus 1. Okay, even up to 0. Okay, log 0 1. Okay, so all these values indicates about the acids. So not only 6, so all middle values also. So the all middle values means so from 7, from 6.99, from 6.99 to exactly up to 0. So all the, for example 5.65, so whatever the value, the total values from uh, 0 to 7, 0 1 2 3 4 5 6 7, not 7, just leaving 7. So all that values indicates acids. If pH equal to, now we can write a general statement that for acids pH is equal to 0 to 7. So 7 it is not possible. You can say 0 to 6.99. So all these comes under for acids. So now we take the calculation for bases. And we know that if H plus concentration is less than 10 power minus 7, means here we are defining the bases also in terms of H plus only, okay, because we need to take any one criteria only, H minus or H plus. In pH scale, the Sorensen took only the H plus criteria to explain the acids and also bases. So if H plus concentration is less than 10 power minus 7 moles per liter, so it indicates base. Okay, so what are the possibilities? What are the possibilities for less than 10 power minus 7 means less than 10 power minus 7. So even 10 to the power of minus 7.1 also. Even 10 to the power of minus 7.1 also it is less than 10 power minus 7. But for simplicity we are writing 10 power minus 8. Least to that 10 power minus less than 10 power minus 8 means we can write minus 8, minus 9, minus 10, minus 11, minus 12, minus 13, minus 14. We can write more examples, more values also. But generally it was observed that the pH values are up to 0 to 14. Okay, start from 0 ends with 14 for maximum acids and bases. So if say for example if you take the pH equal minus log 10 power minus 8, so what we will get? pH equal 8 log 10 and pH becomes 8. Means if you take a 10 power minus 8, we are getting the pH equal to 8. You see in the same way if you take 10 power minus 9, it becomes 9, 10, 11, 12, 13, 14. Means finally we can say for bases pH equal to 8 to 14. So not exactly 8 to 14. So above 7. Above 7 means we can say 7.1 also. 7.1 to 14. So all these values, the pH, if the pH of a solution is for bases the pH is from 7.1 to 14. If we get any fractional value between this, we say it is a base. Now see what about the neutral solution? For neutral solution means just like water, just like pure water. H plus equals OH minus equal 10 to the power of exactly minus 7 only. If less than 10 power minus 7, if H plus is less than 10 power minus 7, so that is the base. If H plus is greater than 10 power minus 7, that is acid. If H plus is exactly 10 power minus 7, that is neutral. So therefore, what is the pH? pH equal minus log H plus 10 power minus 7. So that we will get pH equal to 7 log 10. That is equal 7. Means for a neutral solution, pH equals 7. So it is exactly a single value. If it is 7 point, at least it becomes 7.01 or 7 point something, it becomes base. If it is less than 7, at least the fraction points of less than 7, for example, RD base 6.999, that treated as acid. Means if exactly pH equals 7, then only it will be treated as a neutral solution. Okay, this total thing is treated as a pH scale. So we represent that in the form of a, so what we can write the pH scale means, so we'll start from 0, 1, 2, 6 up to 6.99, okay, 7, even 7.01 also takes the base. Okay, see, from if the pH value from 0 to 6.99, it indicates acids. If exactly 7, that only indicates neutral. If some value will be greater than 7, they known as base. So for acids, pH 0 to 6.99, for bases 7.001, whatever it is, just some value greater than the 7, it will be treated as a basis. If pH equal exactly 7 only, then that will be treated as a neutral solution. Okay. For example, if you take hydrochloric acid, it's a strong acid, so pH will be uh, less than 7. If you take sodium hydroxide, so it's a strong base, so pH is greater than 7 value. Means we are also able to compare the strength, means the strength, that is a strong, weak acids and bases with the help of pH. For example, if pH equal to, say I am taking two examples here to get the 1 point. For example, pH equal 1, a solution is there, pH equal 2, a solution is there. We have to compare the strength of this acid and this acid. So here there is two solutions are there, which is having one is having pH equal 1, second one having pH equal 2. So which is the strong acid? Means in terms of H plus concentration. So actually pH equal 1 means what is the H plus concentration? H plus concentration we will get 10 power minus 1, or by substituting it in the formula. If pH equals 2, what is the H plus concentration? 10 power minus 2. So which is the higher one? 10 power minus 1 is greater than 10 power minus 2. Yes, say 10 power minus 1 is greater than 10 power minus 2. So pH value 1, then it will be the strong acid compared to, more strong compared to the pH equal to 2. For example, if you take pH equals 6, pH equals 6 means what will be the H plus ion concentration? When you got the pH equals 6, if H plus equal 10 power minus 6, then only we will get pH equals 6. So 10 power minus 6 is very less when compared to the pH equal 1. Means here you can say if pH value is less, that will be the strong acid. If pH value is more, it indicates the less H plus concentration. Less H plus concentration, so we can say it is a weak acid. Means this pH also mainly useful not only to compare the acids, bases, neutral solution, it is also useful to compare the strength of acids and bases also. So here we can say from left to right. So what we observed here, 0 is the strong acid, 1, 2, 3. As pH increases, acidic strength decreases. So from left to right I am writing, from left to right. Acidic strength decreases. means it is observed that you can say acidic strength is inversely proportional to pH. Just for the calculations, I am writing this formula. Okay, if pH is less, more strong. If pH is highest, that is less acidic. Okay, so now compare this for bases. Okay, you have to write it again. Okay, or you can take a case 2. Now see, for bases, compare the bases. If pH equal to, again we are comparing the two solutions. If pH equal 8, if pH is equal to, we are taking 10. Okay, when you get the pH equal 8, when H plus is equal to 10 to the power of minus 8, then we will get the pH equal 8. Then pH equal 10, when we will get the 10 pH value 10, if the H plus concentration is 10 power minus 10, so by substituting that H plus in minus log H plus pH formula, we will get the pH 10. So here H plus concentration 8 minus 8. So here main important, then H plus equal 10 power minus 8 means what is the OH minus 8? Sorry, OH minus concentration 10 power minus 6, because H plus into OH minus the product is always 10 power minus 14. So yeah, it is only minus 8 and then OH minus concentration and the 10 power minus 6 molarity. Same pH equal 10 only, 10 per H plus equal 10 power minus 10. So H plus equal 10 power minus 10 and what will be the OH minus concentration? It is just 10 power minus 4. So now tell me, now just guess which is having more OH minus concentration. So pH value 10, pH value 10 only, it is having the 10 power minus 10 H plus. So 10 power minus 10 H plus is automatically that is 10 power minus 4 base OH minus. To compare the bases, we check the OH minus concentration. So if pH value is equal to 8, the OH minus will be 10 power minus 6. If pH value is equal to 10, H plus equal 10 power minus 10 and OH minus is equal to 10 power minus 4. So which is the highest one? 10 power minus 4 is the highest one. In the same way, if you take pH equal 14, if you take pH equal 14, what is the H plus concentration? H plus concentration equal 10 power minus 14. 10 power minus 14, then whatever the H plus concentration, sorry, whatever the OH minus concentration, OH minus concentration is 1. Okay, so means as a pH value, because H plus into OH minus 10 power minus 14 kabatti, so means as a pH value increases, basic character also increases. Means it is exactly opposite. You have to remember that it is exactly opposite to the acids. Means here you can say same from left to right. From left to right. Basic strength increases. Basic strength increases. And here we can write pH value in terms of means and write basic strength is directly proportional to pH. Okay, so it is totally other thing for POH. There is also other concept was also there. After the successness of the pH, there is also POH, other P powers of some compounds, some properties are also given, but the standard one is the pH scale. So this is about the pH scale. So what is the pH for acids, bases and neutral solution? With the help of pH scale, we are able to know the acid, base and neutral solution comparison, and also we compare the strength of acids and separately strength of bases also, means which is strong acid, which is weak acid, which is strong base, which is weak base. We can compare it, and it is limited from 0 to 14 values. Okay, it is akin to Sorensen scale is works at 0 to 14. Okay, next one more important, we calculate it for, we apply it for weak acids and weak bases. Is there any change in the formula? Is there any change in the formula of pH for weak acid, weak bases? Means the original formula there is no change. The pH equal minus log H plus. But for weak acids, we know that H plus concentration is somewhat different. So now we apply it for weak acids. For weak monobasic acids, we applied for weak monobasic acids. What is a H plus? We know that for weak acids, H plus equals C into alpha. We know it in the formulas. For acids, C into alpha. For strong acids, H plus equal by direct the concentration. Then basicity 2 అయితే 2 into concentration అట్లా తీసుకుంటాం. But here it is given weak acid. So weak acid, what is the criteria? In weak acid, directly we can't take the acid concentration. We also have to consider the degree of dissociation. Then percentage కూడా మనం find out చేయాలి. Extent of dissociation కూడా we have to consider. సో నార్మల్గా స్ట్రాంగ్ యాసిడ్కి అయితే నియర్లీ 100%, స్ట్రాంగ్ బేసిస్ కూడా 100% కాబట్టి దాన్ని మనం we can't take care of for that. But here we have to consider the percentage of dissociation of that acid. If you take the OH minus, that is also for base. So for weak acids, we know the formula H plus equals C alpha, and H plus equal C is equal to what? Again we have the C is alpha, so alpha equals root Ka by C. So on this we will get H plus equal to, we can take it as C cancel and becomes what? And it becomes root K into C. Here it can be written root C. One root C get cancelled, remaining one root C. So root K into C. Now we apply it for pH. So for weak acid we have to formula minus log H plus. In the H plus, what is there? Minus log Ka into C. So the pH equals minus log Ka into C whole power 1 by 2. General logarithm calculation. So pH, so which is power in the logarithm value comes to the starting point, become minus 1 by 2 log of Ka into C. pH equals minus 1 by 2. We know it is log A into B. Log A into B means we can write log A plus log B. Okay, this can be this is treated as the formula for it. pH equals minus 1 by 2 log Ka plus log Kc. So here, so just take it as equation 1. So we know that after the success test of the pH, there is also introducing pOH, other values. So we write it as a note. pOH is also known as a formula, that is minus log OH minus. P power K means K acid dissociation constant. It was also treated as minus log K. So pKb, so minus log Kb. And even there is one value, one formula is that pKw. pKw means minus log Kw was known as pKw. Means in different formulas, different concept, these are useful as the formulas. Okay, now apply this one in equation 1. So apply it in equation 1. So now from equation 1 we can say this minus 1 by 2, just minus 1 transfer into the inside. So minus log k minus log c. Okay. So in the place of minus log k, we can write what? The minus log k plus we can write the pk, means the half pk minus log c. So this is also known as a formula. Formula for pH of monobasic weak acids. Monobasic acids means which are having basicity 1. So means this is also correct, this is also correct, this is also correct. So similarly we can write same formulas for POH also. Okay, for bases. Okay. Similarly we can write POH is equal to half into P power KB minus log C. Kv is a base dissociation constant. Okay, we are not deriving the total, just we are writing the direct equation. Okay, and we derived the for acid. Simply we can say for POH also. Okay. Okay, next here one more important thing here. If you see, now we see that we compare the pH values of some acids and bases. For example, blood of our body. Generally, it should be neutral. It is not exactly neutral. It is around the neutral. It is having a pH value 7.4 something. Okay, if you take the lemon juice, it is totally acidic character. Means it pH is there greater than the lemon juice acidic means its pH is less than 7. We no need to know the exact value, but we must know whether a solution is acidic or basic. What will be its pH approximate? For HCl, for what is the pH of acetic acid? So acetic acid is a weak acid, but whatever weak or strong, whatever it is an acid. So its pH will be less than 7. Next, sulfuric acid for all acids, weak acids, strong acids. So for example, if you take lime, what is the nature of lime? CaO, lime water, calcium hydroxide, all these are having basic character. So they are having pH value greater than 7. Even if you take the sodium hydroxide. Next, for example, vinegar means that will treat as acetic acid, so it also treat as pH is less than 7. Okay. If you take milk, so milk pH value is taken as generally 6.8, means near to neutral. So blood is just above 7, so near to neutral. So milk is also near to neutral, that is 6.8. Okay, so even egg white, okay, we know the egg white. Okay, egg white is having 7.8. Means all general things are majorly present as a nearly neutral solutions. Okay, next, so how to know the pH value? How to know the pH value means the main important now there is availability of pH meters are there. With the help of a simple meter, just like our pen. So మన పెన్ సైజ్ మనం యూజ్ చేసే పెన్ సైజ్లో ఉంటుంది. సో ఆ పెన్ సైజ్లో ఉన్నదాన్ని జస్ట్ మనం ఏ సొల్యూషన్కి pH ఫైండ్ అవుట్ చేయాలో ఆ సొల్యూషన్లో డిప్ చేస్తే విత్ ఇన్ ఫ్రాక్షన్ ఆఫ్ మినిట్స్లో అది జస్ట్ దానిపైన రీడింగ్ పడిపోతుంది. జస్ట్ లైక్ మనం వెయింగ్ మిషన్ ఉన్నప్పుడు మన వెయిట్ ఎట్లయితే రిప్రజెంట్ అవుతుందో సేమ్ అదే మోడల్లో జస్ట్ pH మీటర్ జస్ట్ లైక్ ఆ థర్మామీటర్ పెన్ సైజ్లో ఉంటుంది. సో అది మనం ఆ సొల్యూషన్లో డిప్ చేస్తే we get the reading on it. What is the pH of the solution? Easily known. But దీనికంటే ముందు, okay, before some years, what we do, the pH is calculated with the help of some paper they known as pH papers. pH papers in the type, they have different colors. If we get a specific color, that will be pH value for acidic, for base, for weak bases, for strong bases. So there is specific colors are there, but to observe the colors maybe it is having some difficulty. But nowadays we are having pH meters. With the help of pH meters, within fraction of minutes we are able to know the pH of other solutions. Okay. This means what is the importance of pH papers means the pH papers are having different colors at different pH values. And ఆ కలర్ బేస్ చేసుకొని మనం దాని pH ఏంటో ఫైండ్ అవుట్ చేయొచ్చు. ఆ pH వాల్యూ తెలిసి దాని క్యారెక్టర్ ఫైండ్ అవుట్ చేయొచ్చు. Okay, so this is about the concept of pH. So there is many number of other formulas are there, many problems are there. So tomorrow we see that formulas. Okay.